sine 3c times sine 6c times sine times sine 9c times sine 12c times sine 15c over sine c times sine 2c times c3 times sine 4c times sine 5c. Try saying that 10 times fast. The trick here is actually, so if you fill in these values, right? So if you plug in c for each of these things, you will get, let me take a look at my notes here. So you get sine 6 pi over 11 times sine 12 pi over 11 times sine 18 pi over 11 times sine 24 pi over 11 times sine 30 pi over 11. Oh, that should be, I'm kind of, this shouldn't all be, it's just 18 pi over 11. Not, the whole thing isn't over 11, so let me fix that. So 24 pi over 11, 30 pi over 11, all over, and then you have sine 2 pi over 11 times sine 4 pi over 11 times sine 6 pi over 11 times sine 8 pi over 11 times sine 10 pi over 11, right? Now, first thing you can notice is that there's 2 sine 6 pi over 11, so they can cancel out, right? We can cancel them because they're the same. Now, if we think about this, using your sort of knowledge of your unit circle, right? If you think about like what's sine 12 pi over 11, well, sine 11 pi over 11 would just be pi, right? So sine 12 pi over 11 is basically just like if this was pi over 11, right? Because it's like pi plus pi over 11. And then 2 pi over 11, 4 pi over 11. Now, if we look at 10 pi over 11, right? 10 pi over 11 would be like pi over 11 above the x-axis, right? Because it's like pi minus pi over 11. But notice how when you have sine pi minus k and sine pi plus k, they're always going to be negatives of each other, right? And that's because they're going to be on opposite sides of the x-axis, so they're going to be opposite signs. So basically, this would be equal to sine negative pi over 11, whereas this would be equal to sine pi over 11, which means that they're going to cancel but leave behind a negative 1. They're negatives of each other, essentially, right? Now, if we think about 18 pi over 11, now 18 pi over 11, if essentially we can subtract pi, right? And we would have what? Sine 7 pi over 11. So basically it's negative sine 7 pi over 11, right? But then again, if we think about 7, so that's negative 7 pi over 11, right? So notice how sine 7 pi over 11 would have the same value as sine 4 pi over 11, right? And that's because sine of pi minus k is equal to sine of k, right? Which again, well, which is because they would be on the same side of the x-axis. And notice how sine of 7 pi over 11, so 7 pi over 11 plus 4 pi over 11 would be pi. So that means that these are equal. And remember how we said that this is basically equal to negative sine 7 pi over 11. So that means that this and this are negative, also negatives of each other, right? So they're going to cancel out and leave a minus 1. Now, think about sine 24 pi over 11. Well, what would be 22 pi over 11 would be 2 pi. So basically, that's 2 pi plus 2 pi over 11. But 2 pi is the same as 0. So basically, it's just sine of 2 pi over 11. So what that means is that this and this are equal. They're equal, so we can cancel them out without leaving anything, just a 1, right? And then now think about sine 30 pi over 11. Well, sine 22. So what's 22 pi over 11 is 2 pi, which is 0. So that essentially leaves behind 8 pi over 11. So this is basically equal to sine 8 pi over 11, which means it's equal to this. So these can also cancel out. So what do we have? We have a 1, we have a minus 1, we have a minus 1, we have a 1, we have a 1. Right? 1 times negative 1 times negative 1 times 1 times 1 is 1. So the answer is choice E. So basically everything cancels out, but 2 of them leave negative signs behind, which cancel out anyway. So you end up with 1 as your answer. So kind of an interesting problem, right? It just requires you to know these little rules about sign, right? Not necessarily like trig identities, but just little properties of sign, right? Using basically the unit circle. So pretty interesting problem. Okay, so in my next video, I will be going over problem. Let me move this out of the way. I'll be going over problem 14. All right. So I will see you in the next video.